So we got the answer in the previous bit of 0.6941 to 4 decimal places, which was that number there. Now, part B, now this is the bit we're likely to find hard. It says, use your answer in part A. So what we've just done, we have to use here to deduce an approximate value for the integral of this thing here. So tan squared and sec squared. Now this is where that thing that we've done at the start is hopefully going to pay off. So I can see there, fact number 3, sec squared is the same thing, is equal to saying tan squared plus 1. So what I need to do, I need to write out for part B, I need to write out that integral. So integral between pi by 3 and 0, they're the same limits as well, so that's good news, of sec squared x dx is equal to the integral of pi by 3 between pi by 3 to 0 of tan squared x plus 1 dx. I'm going to put that in a bracket because there's two things, okay? But that is the same as that. That's what that definition told us from fact 3. I'm now going to split that integral into two things. I'm going to put it into pi by 3 and 0 of tan squared x dx plus the integral of pi by 3 to 0 of 1 dx. It's absolutely fine when you're adding integrals, just split them and do them as two things. If these two things were timesing, as we've seen a lot in C4, we would take it out as a multiply here, but no need this time, okay? Because they're adding, you can just do them to two separate integrals. Now the great news is, this bit here we know was this answer. So I can say that that's 0.6941 plus, and then integrating that, well that's lush, it's just a single number with no power of x. So put the power of x up by 1, is literally just going to be 1x, or just x. So x between the limits of pi by 3 and 0. So I need to do pi by 3 take away 0, so in other words just pi by 3. So that answer from before, if I plus pi by 3, I get my next answer, and I'm going to round that to 4 decimal places because the last one was to 40p. So 1.7413 to 4 decimal places. Okay? Okay, question 2. Question 2 is proof by counterexample. Now these things are normally pretty simple, but I'll show you like an easy mistake to make on this, and I'll try and show you what the logic that you need to use. You may have to use a bit of logic. It says, show by counterexample that the statement, if x is an acute angle, then sine x plus 30 is greater than sine x. So I'm going to let x equal, and the tip I gave you was not to use 30, 45, 60, 90 or 0 because they tend to actually prove the point. So I'm going to let sine equal 1 because that would be an acute angle, wouldn't it? So I've got, what have they got? Sine x plus 30. So that would be sine 1 plus 30. And then I'd find out what that is, and then I need to find just sine x. So sine x would just be sine 1. So I'd have to be back in degrees mode for this because look, it says they're degrees, so unless it explicitly states degrees work in radians, but it does explicitly state degrees here. So sine 31 gives me 0.515 blah blah blah, and then sine of 1 gives me 0.017 blah blah blah. Now that's an issue because look, that answer there is bigger than that answer there. So that doesn't help me, that's useless, that's actually proved their point. There you go, there's my two answers there, sorry. So that's actually proved that point, so that's no use to me, okay? Now, you could get yourself into a real faff in this question and think, oh, I'll try 2 and 2 won't work, and it won't work up until quite a large number. So let's just stop a moment and think of what the sine graph looks like. So sine is an S, it goes through the origin like that, okay? This value here maxes out at 1 for 90. Okay, now we know that it's got to be an acute angle. So if I take a number just by here, I know it's going to be really large. Let's say 89. Okay, that is an acute angle. If I add 30 onto that, then I'm going to be down here. So then it's going to be less by there. Okay, so that's the best way to do it, or at least that's the best way I think to do it. I think if you use any value up to or down to 75, going up towards 89, it'll work. But I'm going to use 89. So let x equal 89. So then I'm going to get sine 89 plus 30, I'll work out what that is, and then I'll do sine of 89 by here, try and let you see what I'm doing. So sine of 89 plus 30 is 0.8746 blah blah blah, and then sine of 89, pretty close to 1, 0.999 blah blah blah. Okay, so what do they say here? They said that this has to be bigger than that. So that's not true. I'm going to say as 0.874 blah blah is less than 0.999. It follows that, and I like to write in what they had originally. So sine x plus 30 is less than sine x in this case. Maybe not always. In fact, I proved a point above where it's not always. I'm going to say in this case. Therefore, by counterexample, I have proved this to be false. Okay. Part B. This might be one that I'm not actually going to go through. I think you're pretty good at these, to be fair. You're very good in C2, so I'll get you started off. But who knows, I might get really into it and think, oh, I'll just finish it off anyway. So, we're looking for the non-quadratic, which is the cot. Everything's got to be in terms of cot. So I need to go and turn my page over. The one with cot. Then now I haven't actually got that in terms of cot. So this is my fifth one that I can generate if I want to. So cot squared theta would be cosec squared theta and take the 1 over, so it would be minus 1. So wherever I see, that's not what I want to do. That's a lie. I want to have everything to have cot in it. So wherever I see a cosec, I need to change it to 1 plus cot squared theta. Okay? So cosec changed to 1 plus cot squared theta. Let's just check this right. Yeah, 1 plus cot squared theta. But I could have had it come round the other way as well. So 15, so 1 plus cot squared theta plus 2 cot theta, and I'm going to bring that 23 over straight away as well, so minus 23 equals 0. Expand out and collect the like terms. I'll try and do it really quickly. 15 cot squared theta plus 2 cot theta. I'm going to get plus 15, but then take away 23 is minus 8 equals 0. I'd then factorise, like I've done all the C1 and C2, so that would be what, minus 120 and plus 2. So a pair of numbers to do that are 12 and minus 10. So factorise 2, 15 cot theta plus 12, 15 cot theta minus 10 equals 0, but then you must cancel down, so we get what, 5 cot theta plus 4, and here we just get 3 cot theta minus 2 equals 0, so cot theta equals minus 4/5, or cot theta equals 2/3. Change now, third letter t, tan, so 1 over, so I'm going to do the reciprocal now. So tan theta would equal minus 5/4. Tan theta would equal 3/2. And I will find the answers just because tan's quite easy because of the fact that it repeats every 180 degrees. So I'm not going to do all silly tomcats here. I'm literally just going to run through really obviously. Take the tan over to the other side. So tan minus 1 of minus 4/5. And the first answer is negative 51. Now if we just look at the answer, it wants it between 0 and 360, so that's no use to me. So literally all I do is say answer plus 180. So first answer, 128.7. And then press equals again, I've got a next one. The next one clearly will be over 360. And then here, I'm going to do tan theta, 3 divided by 2, which is 56.3. And then plus 180 again, 236.3. Now there's a way you can check this if you wanted to. It's not quite as easy as it was in C2. But cosec means 1 over the third letter, which would be sine squared. So I'd write this in as 15, and then sine ans, but then I need that to be squared, don't I? Because it's cosec squared. So I'd bracket all of that and square by here, and then plus 2 over cot, so third letter is tan, so tan ans. Now I'm hoping that this is going to give 23, because that's what it should do. But if I'm wrong, I'm going to feel like an idiot. There we go, it's 23. Now I'm leaving that exam knowing I have those 6 marks. I cannot possibly not have those 6 marks. And it's a very nice feeling in the exam knowing that you've got those, trust me. Okay, now the next one, implicit differentiation. Watch out, they're going to expect you to do a little bit of C3 work here. In terms of the differentiation, okay? So we've got x cubed minus 2x squared y plus 3y squared equals 3, okay? So I'm going to differentiate that through implicit differentiation. So whenever I see a y, I just differentiate it like I normally would, but then I have to put a dy by dx with it. But also here, I've got a product rule because I've got these two letters timesing together. So here, I'm going to note that I have u dot v straight away. So u, now I always include this sign here and make your life a million times easier. You don't have to, but it's a bit harder to work out what you're doing. So u is minus 2x squared, v is y. U dash would be minus 4x, and v dash would just be 1, but then times by dy by dx. So what we tend to say when you're in good practice is just dy by dx. Okay, so let's go through differentiate that thing now. So that would differentiate to 3x squared, and then it's going to be u v dash plus v u dash. So I'm going to get minus 2x squared, and then times by dy by dx, and then I'm going to get plus minus 4x times by y, plus 6y. Now, whenever you differentiate a y, you have to put a brackets dy by dx after it, equals, and then 3 differentiated is just 0. Okay, so what we do now is you collect everything with dy by dx all on one side, everything else over on the other side. Now I can see here that's going to be a minus, so when that goes over that will become plus, and that's going to become minus. And I'm going to make this 6y go to the front just so it looks nice, just so it's positive. So dy by dx minus 2x squared dy by dx would be equal to 4xy minus 3x squared, and then I'm going to factorise by dy by dx here. Now you get really quick at this in time, so dy by dx taken out as a factor, brackets 6y minus 2x squared is equal to 4xy minus 3x squared, and then you just literally plug that over, but you could have done that in one go. I tend to do it myself, where I take the factor out and think, right, what would be that bracket, and just divide by it straight away. But I wanted to show you what I'm doing properly in this video. So then we asked to do something as well. It said find the value at the point minus 2, minus 1. So at minus 2, minus 1, not a bad idea to write above it xy. So x is minus 2, y is minus 1. Literally just chuck it into there with brackets and you can't go wrong. So you just set them up straight away and show you how easy it is. So 6 brackets and minus 2 brackets squared. Okay, so the first one is 4x, isn't it? So 4xy, so x is minus 2, y is minus 1. And then is x squared, so x was minus 2. And then coming down to the bottom, then it was y, so that's minus 1 there. And then it was x at the back, so minus 2 there. And it comes out as 2/7. So minus 2 minus 1, dy by dx equals 2/7. Okay. Next point. Now, I think number 4 is pretty tricky. Okay, so let's start a fresh page. Yeah, the reason why I thought number 4 was really tricky was they usually give us x and y, but they've given us x and dy by dx this time. So we're actually going to have to go and find out what y is at some point. And they've given you 10 marks there. And I got myself into a right faff the first time with this question, so be careful. This is a tough question. Okay. So it says find an expression for dy by dx by dt in terms of t. Now that bit's pretty simple. So 4a. So x was equal to 2t cubed. And the first bit wants me to find dt by dx, which is literally as simple as saying 6t squared. Okay? So from here, what do we have to do next? So part A done. Part B, find an expression for d2y by dx squared in terms of t, and hence show there's no value for t, which d2y by dx squared is equal to 2. Now that bit's not that bad. You have to learn this formula though. So d2y by dx squared is equal to d by dt, so you differentiate the differential, and then you times that by dt by dx, which effectively will cancel out these two dt's, d squared y, dx, dx squared. Okay, so from here, I need to differentiate the differential with respect to t, so that's going to be 2 plus 12t squared. So I'm going to say, therefore, d2y by dx squared is equal to, what did I just say? I said 2 plus 12t cubed, and then I need to times it by, now be careful, if we look back at this, it says dt by dx. I had dx by dt, so dt by dx would be equal to 1 over 6t squared. So 1 over 6t squared here. Okay, so that is going to basically be that divided by that, and I can see that they're all even numbers, so I'm going to divide each of these things by 2. So I'm going to get 1 plus 6t cubed all over 3t squared. Now that is actually as far as it will go, because there's no t in this bit here, I can't cancel that t, but what I could do if I wanted to do is, because this is all over one denominator, I could split it to being 1 over 3t squared plus 6t cubed over 3t squared. Now that would cancel quite a lot, wouldn't it? So 1 over 3t squared plus, so that's going to go to being 2, just 2t. So that's quite nice in some respects, especially if I needed to differentiate that again or do something. But it may just be a waste of time. You may prefer seeing it in that form there. It doesn't actually matter. They're the same thing. Okay? And then it's what did it want me to do part B? It said, and hence show there's no value for d2y by dx is equal to 2. Okay, so I'll just chuck that equal to 2. I'm going to go back to that very first version I wrote. So I'm going to say 2 equals, so I'm literally just replacing that for 2 and then putting that bit in. So 1 plus 6t cubed. So 1 plus 6t cubed over, I think I made a mistake here, haven't I? The differential, yeah, t squared. T squared. So this should have been t squared here, so that would have just been plus 2 by there. Plus 6t squared all over 3t squared. Okay, so bring that 3t round and you get an expression which can't possibly be true. Okay, you've got 6t squared is equal to 1 plus itself, which can't be true, because if you think of any number in the world, if you add 1 to it, it's not the number it was before. Okay, so literally I just make it, or here's another way of doing it, take the 6t over, 0 equals 1, because you just take away the 6t squared, say this is not true, as 0 does not equal 1, therefore no value of t will give d2y by dx squared equals 2. Okay? Right then, your part C now. I think the layout is the most important bit of this. Okay, so I'm going to say by here the way that I normally set it up: x dx by dt, y dy by dt. Okay, bear in mind I don't actually know what either of these two things are. X was 2t cubed and this was 6t squared. Okay, let's have a look. So it says, given that y equals 10 when t equals 1, find an expression for y in terms of t. Now, they gave us dy by dx straight away, but we usually use this formula. dt by dx times by dy by dt. Now let's sub in the information that we've got that we know that makes that already. So dy by dx was 2t plus 4t cubed. dt by dx was 1 over 6t squared times by dy by dt. Okay, so what I'm going to do now, that's effectively like dividing by 6t squared here. I'm going to take that over and it's going to effectively become just times those things there. So I'm going to get 6, well in fact actually let's solve it straight away. 6t squared times by 2t would be 12t cubed, and then this would be plus 24 t to the power of 5 would be equal to dy by dt. Now dy by dt, I now know is this thing here. I could say it's 12t cubed plus 24t to the power of 5. Now that is differentiation to work that way. And again, if I went that way, if I differentiate going this way, the inverse process of differentiation is integration. So I'm going to integrate that. So I'm going to put the power up by 1, so it can become t to the power of 4, and I'm going to divide by the new power. So 12 divided by 4 is 3. Again here, power up by 1, t to the power of 6, divide that by 6 is 4. But don't forget you plus a constant term there because we integrate it. Okay. Now this is when I can use the information they told me, which was y equals 10 when t equals 1. So therefore y equals 3t to the power of 4 plus 4tx, t6, sorry, plus c, and we told that y was equal to 10 when t was equal to 1. Now, anything to any 1 to any power is always 1, so in some respects I didn't need to write it, but that's going to be 10, 3 plus 4 is 7, plus c, so c is equal to 3. Therefore, y equals 3t to the power of 4 plus 4t to the power of 6 plus 3. Okay. Next question, iterations. Now iterations are very, very, very easy as long as you know the trick that we talked about in class. So they've given me x0 is equal to 1, and they want me to find up to x4. And they want me to go to as far as 5 dp. Now all of these must go to 5 dp. You don't actually round them, this is properly rounded to 5 dp here, but they must all show at least 5 decimal places. If you don't do that, you'll lose a mark. Okay. Now x0 equals 1, so all you do is put in 1 equals. So 1 equals, and then you just set it up there, wherever you see an xn, you just press ands. So 3 over 1, not 1, sorry, ands plus 7. Okay. Now, all I have to do is keep pressing equals and it answers it for me. So it's root 6 divided by 4, and then it's 0.62777 ... to show it continues, so don't round that. Then it's 0.627136 ... and then it's, and this is the one I do actually round properly to 5 decimal places, 62716 to 5 dp. 2, 3, 4, 5. Yes. Okay. Now I prove that by taking upper and lower bounds. So I do f of. Now I treat that as 60. I've just put an imaginary 0 on the end, so it's not 6. It's 60. Take off 5. Add on 5. So take off 5 will be 55. Add on 5 will be 65. 55 will be my lower bound. So f of 627.155 equals, and f of 0.627165 equals. Now that goes into the original formula, so this one here. So I'm going to do x cubed, so 0.627155 cubed, plus 7 lots of 0.62627, what was it, 627.155 squared, take away 3. Now if it's equal to 0, one answer should be just below 0 and one answer should be just above 0, so I'm expecting to see a negative answer here. Lovely, negative 6.1. The fact it's in stand form just tells you it's very, very, very close to 0. So I'm going to say equals minus 6.15 times 10 to the minus 5, and then change those to 6's. And then look, it's gone positive, so that's 3.8, no, it's not 3.81 times 10 to the minus 5. But it's not that minus that we care about, it doesn't matter. It's this minus here, minus then plus. So all you say is as a change of sign, therefore alpha equals 0.62716 to 5 dp. Okay, that's like 5 marks. It's nuts. It's a lot of marks. Okay, so 6A, we are looking at the differentials here. Now you're going to be using product rule, quotient rule definitely, chain rule possibly. If it's hard, use chain rule. Okay. the first one is actually quite a hard one. I'm going to use the chain rule. So I'm going to say let u equal what the bracket is. So let u equal 5x cubed minus x. So y equals u to the power of 10. I differentiate this thing with respect to x. So it becomes 15x squared minus 1. I differentiate this thing with respect to u, which would be 10u to the power of 9. dy by dx would equal du by dx multiplied by dy by du, because it would cancel out the du's. So I'm literally just going to times those two answers together. So 15x squared minus 1 times by 10. But bear in mind, u we said was this thing here, so we just chuck u in terms of x again. So 5x cubed minus x to the power of 9. Okay, and then I'm just going to make it look a bit nicer, so I'm going to put the 10 at the front and just put the two brackets touching. Like that. Okay, the rule that I've told you to try and get in your head is times by the power, and then times by the differential of the bracket and reduce the power of the bracket by 1. And that would have worked here, but it wasn't the nicest one in the world. And the same with this one, they weren't the nicest differentiation questions. So we've got sine minus 1x cubed, sine minus 1x cubed. So again, I'm going to let u equal x cubed, so y equals sine minus 1u. Okay, now this is where you'll want to use the formula booklets. Certainly for the second bit, which I'm going to use now. I can do the first bit, it's 3x squared. dy by du, I'm not certain on, so let me just check. Okay, so what is it? Sine minus 1. Okay, so there it is. Now they've just given it to me in terms of x, so I just need to change an x to a u. So 1 over the square root of 1 minus u squared. 1 over the square root of 1 minus u squared. So then I just times these two things together. So dy by dx. Now that times by that as a fraction, you just times the numerator. So it just becomes 3x squared times 1, which is 3x squared, all over the square root of 1 minus, now u was this thing here, was x cubed and then squared. So times by itself will be x to the power of 6. Okay? Part C. Product rule. We've already used the product rule very briefly in the implicit differentiation. So we've got x for ln 2x. Now I'm just going to write a rule here that I know that d by dx of ln x is 1 over x. That's a really important rule that we need to know. Now, this thing here is in terms of u dot v. So u is equal to x to the power of 4, v is equal to ln of 2x, so u dash would be equal to 4x cubed, v dash, so of ln x would just be 1 over x. Now we've got a way of remembering that, which is the differential over the original, so the differential would be 2 over the original, which is 2x, and 2 over 2x just becomes 1 over 1x. But in terms of anything, ln to any just normal number of x, so like ln of 10x would just be 1 over x, so it goes 10 over 10x, which would cancel down to being 1 over x. It's just when this gets powers that we need to remember that differential over original, but it's worked quite nicely here as well. So, product rule states that u v dash plus v u dash, so I have to basically just multiply across the diagonals, so I'm going to get y dash is equal to x to the power of 4 times by 1 over x, and then plus 4x cubed times by ln of 2x. So that's going to become x cubed plus 4x cubed ln of 2x. And then in C3, we should always try and take out any factors if we can. So x cubed and x cubed in both. So it's going to be 1 plus ln of 2x. Okay? 4 ln 2x. Okay? And then part D, e to the 4x. These ones are quite fussy and they've chucked in the chain rule again. Plus 3 even to the power of 6, which is equal to u over v. Okay, so u equals u dash equals, so u is equal to 4e to the 4x. So u dash is equal to 4 e to the 4x. V is equal to this bracket here. Done it again. And then v dash is equal to, now it's the differential of the bracket, so that's 2 times by the power, so that's 12, and then the bracket you drop by a power. But if in doubt, chain rule it out. You can go and do the chain rule to go and prove that if you wanted to, okay? Now, the quotient rule. Now this is actually given in the exam, but slightly different terms the way I like to work with it, okay? But I will show you. So they've said here, they've done it in f of x notation. So they've said there, it's the derivative of the top function times by the original of the bottom. Take away the top function times by the derivative of the bottom all over the derivative of the bottom squared. Okay? Now I like to write that. I remember the product rule. So if we look at the product rule up by here, where was it? This thing here. Basically, these two guys just flip around, and because they flip around, you just have to change it to a minus. That's how I remember it. All over the bottom one. So v squared, okay? It's just the way I learned it, it's just stuck in my mind, but if you want to, you can actually call that f of x, that g of x, and then just use their notation, and then you're using the formula booklet, aren't you? Okay? So, from here, what have we got? We've got v u dash, so that's this diagonal here, so that's going to be 4e to the 4x, and then 2x plus 3 to the power of 6, take away, and it's going to be this one times together, so it's going to be 12 times by e to the 4x, and then 2x plus 3 to the power of 5, all over this bracket here, but then squared, so that's going to change to a power of 12. Okay? Now, as I said before, we must cancel out. I can see loads of common stuff here. So 4 and 12, so 4 goes into both those. E to the 4x, e to the 4x. Lovely, that comes out. And this whole bracket here, so you always just take the lowest power. So we'll take out 4 e to the 4x and then 2x plus 3 to the power of 5. So what do I need to make that?